Hello students, now we come to a very important discussion, mole concept. Many of us may not be very clear about what does this mole mean. One mole, as the definition says, is the amount of a substance that contains as many particles as there are atoms in exactly carbon 12 isotope. That means if you take 12 grams of carbon 12 isotope, as you know, carbon has various isotopes, carbon 12, carbon 13 and carbon 14, but out of which carbon 12 is most abundant and most common. Carbon 13 and carbon 14 are not really very common, and they are radioactive in nature. So we take exactly 12 grams of carbon 12 isotope, and if you are able to count the number of particles in that, suppose we assume that the number of particles in 12 grams of carbon 12, let us just assume 12 gram of carbon 12 isotope, suppose it contains y number of particles. Now I take any other element and count y number, say y number of sodium atoms. Now if I am able to take the mass of this y number of sodium atoms, that will be known as 1 mole of sodium. That is the meaning of this definition. So the explanation is given here. Now the mass of 1 mole of a substance in grams is called as molar mass. That is the easiest way to express 1 mole of a substance. Whatever the atomic mass or molecular mass of a substance you get, if you express it in grams, that will be equivalent to 1 mole. Say for example, hydrogen. Hydrogen atomic mass is 1, so molecular hydrogen mass is 2. How do you get 2? So if you take 2 grams of hydrogen, that will be 1 mole. Okay. Now if you take say 23 grams of sodium, 23 is the atomic mass of sodium. So when we take 23 gram of sodium, that also makes it 1 mole. So the easiest way to calculate molar mass, mole is expressing molar mass in grams. So you can see from Avogadro's law, we know that 1 mole of any substance contains 6.023 into 10 to the power 23 number of particles. In some books you may find instead of 10 to the power 23 they write 6.022 at times they write. It doesn't mean it is same, because the number is very big. 10 to the power 23 is a huge number. So Avogadro's number is expressed by the symbol Na. N stands for number, A stands for Avogadro. So molecular mass of water, we all know, is 18 unit. Please try to remember these values. Okay, how do we get 18? 2 hydrogens, so 2, 1 oxygen is 16, so if you add them up it comes to 18. Now if I take 18 gram of water, that will be equivalent to 1 mole, or molar mass of water can be considered as 18 gram per mole. When we write molecular mass, the unit is U, unified unit, and when we write molar mass, we write unit as gram per mole. So there is another example of carbon dioxide. Molecular mass is 44 units, and if I take 44 grams, that will be 1 mole. So according to Avogadro's law, 1 mole of any gas occupies 22.4 liters at STP. So you can find there is a correlation between number of particles and volume of a gas. But remember, volume will come into play only if it is gas, and that also it has to maintain the standard temperature and pressure. So we find there is a correlation between mass, molar mass, number of particles and volume of different substances. This is a very important formula which will help you to solve many numericals easily. So small n represents here number of moles. As you can see, everything is written. Small n represents number of moles. I use here W. In some books you may find it's written small m. but I avoid writing small m because quite often when the students write small m and capital M, there is hardly any difference. So what is the difference between W and M? W is mass of a substance, that is how much has been given to you, and M is molar mass of a substance. N is number of particles in a given amount of substance. Na, as we all know, is Avogadro's number. V is volume of a gas at STP, which we may need to calculate, and 22.4 liter is the volume of a gas occupied by 1 mole of a gas at STP. So using this formula, we should be able to solve a lot of numericals. I have solved some of the numericals using both unitary method and the formula. Whichever way you find it easy, you can do. But during exam, we need to take care of time. So in that time, during that situation, I think better to use the formula. But you should be very clear about the formula. So here I have given you a numerical. Calculate the number of moles in 6.8 gram of carbon dioxide. So what is given to me and what we are supposed to find out? I have been given mass W, okay, as per the formula. So W is given to me 8.8. I am supposed to find out number of moles, that is small n. Now which correlation I have to choose? I have to take this correlation because n equals W by M. I am supposed to find out small n and W is given to me. And since the molecular formula of the compound is given to me, I will be able to calculate the molar mass. So molar mass of carbon dioxide is coming to be 44 gram per mole. Earlier also you have seen. Now I have solved it using both the formula and statement. So you see statement, how do I write? Since 44 is the molar mass of carbon dioxide, that means 44 gram of carbon dioxide is 1 mole. Then you use unitary method, therefore 1 gram of carbon dioxide will be 1 by 44 mole, and I have been given as per the question 8.8 gram. So using unitary method, we find the answer to be 0.2 grams. Now the same numerical, if you want to do by using formula, then what we write? Given mass of carbon dioxide W, that is 8.8 gram, molar mass given calculated 44 gram per mole. So we know N equals W by M. So you just feed in the formula and you get the answer. One thing you need to be careful, when we talk about quantity, then we write MOLE, and when we write mole as a unit, we simply write MOL. Then another problem, calculate number of moles in these many molecules of ammonia. So molecules have been given to me. So which formula to be used? The formula to be used is N, and I am supposed to calculate number of moles. So I have to choose this equality. N equals N by Na. So let us see how it has been done. So using statement, how we do? We know that 6.023 into 10 to the power 23 molecules of ammonia is 1 mole according to Avogadro. Then as many molecules given to us, you can calculate. And using the formula, you have to write what is given. Here molar mass is not important to calculate because molar mass is not coming into the picture. So we simply use the formula N equal to N by Na, and we get the same answer using. Okay. So depending on what is given to you and what is to be found out, you have to choose the appropriate correlation. Third one, let us see. Calculate the number of moles of oxygen gas occupying 2.24 liters at STP. So here what is given to me and what am I supposed to find out? I am supposed to find out number of moles, that is small n, and what is given to me? Volume V. So which relation I have to take? N equals V by 22.4. So if you use the statement, we know 22.4 liters of any gas at STP will be 1 mole. So 2.24 liters will be how much? And by using the formula N equal to V by 22.4, you see whichever way you do, the answer is coming to be same. Now sometimes we may not ask you to calculate the number of moles, we may ask you to find out anything else. Say number of particles in 34 gram of ammonia. So here I have to calculate N and I have been given W. So which correlation I have to take? I have to take W by M equal to N by Na if I want to use the formula, or if I want to use the statement, then also we can do. So first of all, you have to calculate the molar mass of ammonia, because you have been given mass of ammonia. So molar mass is important. So molar mass of ammonia is 17. So 17 gram of ammonia contains Avogadro's number of particles. So 34 gram will contain how much? Just do by using unitary method. But if you wish to do it using formula, so as I said, W by M equal to N by Na. W is known to us, M is known to us, Na is known to us. You need to calculate N. So I hope you understood and you have done the homework, as I sent this work much earlier. Thank you.